today we've got the OV7670 cam together with Arduino Duo, and we will print out the results of the photos on the terminal. So let's make quick a photo of our test glasses and let's wait for the results. It takes about a few seconds to take a photo. And here we go. Right there on the terminal we got the glasses visible. So let's take a look at the application. So we are in the project. So let's take a look first at the ASF, what we have added. So the 2-wire interface, the driver and the API, the timer counter, the USB device as ACDC to send data through it, and some delay routines. So that's all. And in the main.c we can see a maker for the timer 0, and we will use it as a toggle of a pin, the M clock for the camera, and it will toggle the pin at 10 MHz, somewhere around it. Next one we got macros for the pins, and also right here I added a macro for the register that holds up the data of the PIOC inputs, so we can read the data coming from the camera at a fast rate. Prototypes of functions we got here, so we don't get warnings. Next on the configuration of the camera pins, so enabling the clock for the PIOC, the setting of the reset pin, power down pin, and setting up the PB25 as a peripheral for the timer counter 0. So this is our M clock for the camera, 10 MHz. Next on what we got here is the configuration of the 2-wire interface pins, and right here we got the inputs for the camera pins. Next on we got variables. This one holds up the raw data coming from the camera. You can use it to print on a display if you have one, or you can print it through the USB and save it somewhere on the computer. But we don't use it here. In here we use this variable, and it holds up the 10 times less pixels than the original one, and it prints it on the terminal. Next one we got a function to grab frames. First of all I clean up this variable, and out here I wait for the vertical synchronization. So if it goes high, it goes here, and if it goes low, it goes down here. So we're at the stage of reading the pixels, so we wait for the pixel clock until it's high. If it's high, then we read the register that holds the PIOC data, and we have to shift it by 1 because our D0 is at PC1, so PC0 is not used, so we have to just switch it a little bit by 1 bit. And next on we can save the raw data here, and also we can sum up the pixels for the image that's 10 times less pixels. Okay, so next on we wait until it's getting low, then high, and right here you could read the pixels that are responsible for the color, but we don't use it here, only grayscale. Okay, so after this is done, we got the picture, and we have to do something about the variable that holds up 10 times pixels less. So it's an average of 100 pixels. So we just divide it by 100 and we calculate here the mean pixel. And we do this because we want to print out here an ASCII that is compared to the mean. So something like this is responsible to something around less than this value, and the higher we got, the more filling of the screen with the ASCII. Okay. And after this, we got the function to set up the cam. This is a very important step. You have to make sure that the camera is configured. If you don't have it configured, it simply won't put up anything useful. So this code right here I got is I found it somewhere on the internet, and it seems to be working. It scales down the image by 2. And one thing I made here to accommodate for the speed of the data coming, I had to reduce the clock to something like this. So you can try to, let's say, make the clock faster. We will try that in a second. And in the main function we got the usual, and also in the main loop we toggle a LED. This is the PB27, so the D13 LED, and we get the frame of the camera and print it through the terminal. So let's try and compile it. And one thing to mention here is the size of the RAM which is used. So it's like 90%. And if you don't want to use this variable, it will drop down to 12. So it's up to you to use it. Okay, so let's maybe program the board. Okay, connect to it and write. So we will see first of all the behavior of the cam if it's turned on, and also if the clock is still correct for it. Okay, so I still got the glasses in front of the cam, but it takes a few frames of the camera to see something. So the third image, and we still don't see anything. But I think the clock is correct because we don't see any transposing of the image. It's all up and down lines. Still nothing. Oh, we see something. So the camera is trying to see something. Okay, so it's visible. It took it a few frames, but yeah, it is working now. So thanks for watching. Hope you find it useful in your projects. So as you see right here, you don't use too much of the space of the program and the data if you don't use the whole raw image. So you can use it anywhere you want in your project. Hope you find it useful, and see you in the next one.